Hello, people. It's your good old pal Diego here of another Miss Munoz question review, I suppose. Um, this one, the second question, really tripped a lot of people up, and I'll do the first one just for review, anyways. Um, yeah, let's get right into it, shall we? So this was our diagram, right? We had two poles. The pole was 10 meters long, and there's a 40-degree angle of depression going down. Put a little zero here with this being her degree sign. There's a 40 degree angle of depression going down to the base of this other pole, and then there was a 79-degree angle of a depression to Zev here. And we have to find we had to find a couple values first. We had to find the distance of this, the distance of this, which we'll mark as y. Okay, now that we know what we're solving for, here's what we're gonna do, right? Um, if you don't wanna like listen to question one repeated, you can skip up to this one because I'm sure that's where a lot of people got tripped up. I'll probably leave a timestamp somewhere in the description. Let's do this one though for now, okay? Now we're given this 40th degree here, right? Because it's in the triangle, we know is probably what we're going to be using, and it's saying that we're trying to find the distance from one pole to another. So that being this ground here, I just made it up here for simplicity's sake, meaning that we're solving for x here. We know that our this side is going to be 10 meters, not millimeters, because this was going to be our opposite. So we're going to be doing a well, what kind of problem are we going to be doing? Well, it's our opposite. We're not using our hypotenuse, so we're going to be doing our adjacent and our opposite, making this a tan problem. Tan of what? Well, do you guys see a degree measurement here? I sure do. The tan of 40 degree is going to equal our opposite, which we know is 10, over our adjacent, which we know is... Oh, I actually don't know what this is. Because we have to solve for it, don't we, guys? So we're going to multiply both sides by x, which is going to equal something like tan 40 x is equal to 10. But what are we even trying to do here, right? Well, we're trying to isolate x, obviously. So to do that, we're going to divide both sides by the tangent of 40. We will not be subtracting this because we already know what the theta value is. So, I hope that made sense because, I'm sure some people remember that -1 thing. We're not doing that here. Man, I've had to edit myself twice here, huh? All right, well, we're not going to be doing that because we're subtracting just tan when we have like a mysterious theta value. But because here we have a known theta value, we're subtracting the whole thing. But you're not subtracting it, you're dividing the whole thing. Point being, is going to equal out to this. Oh, this is kind of awkward. Do any of you guys know the tangent of 40? Divided by 10, of course? Apologies, people. But I really didn't know the answer to this, so our good old calculator equates to this leading to 10 over 0.834. And then we're going to equate that to equal roughly 11.9175. We're going to round it to our hundredths. So this is going to be our x. Well, this is embarrassing, huh? 3 re-records in one video? Alright, well, I was pretty silly when putting it into the computer calculator. So I'm going to show you how to do that, right? It was a tangent of 40, which you do like this, which was that. Then you do 10 divided by a 0.0. No. See, that's gonna mess me up there, right? It's 0.83 or whatever, leading to your value being a little bit less than that if you like the whole thing, because this is like really rounded. But just be aware of that, please. But I'm sure a lot of you people already knew that, right? So this is where a lot of people got stuck, right? Question 2. Well, if you guys remember a little while back, Miss Munoz had I'm pretty sure it was a bell work on alternate interior angles. You guys remember that guy, don't we? Well, that's how we actually figure this one out. Because we're trying to figure out what this distance is, but, we don't really have the hypotenuse and we don't have any degree measurement here. Theta, by the way, guys. So to get theta, we're going to need to use our alternate interior angles, okay? That's because this and this are alternate interior angles as shown in the diagram, which I'm guessing is what was hinting towards the answer here. But can you guys guess what this is going to be the alternate interior angle of? I'm not going to make you. It's going to be right here, right? In this corner. 79 degrees, right? Yeah, I'm sure that's all you guys needed, right? You guys can do it from here. So end the video if you can. But if you just want to see me because you like hearing my voice, which I really don't, is going to equal to the opposite of 10 over y. Yes, sorry. It's going to equal to this, right? Well, we've seen this before, haven't we? We have. We're just going to do what we did over here. Multiply by y, divide this, so that y equals 10 over the tangent of 79. Okay, now I'm going to pull out my good old buddy, the calculator. So here, don't read the answer, guys. Here, we're going to do the tangent of 79. Calculator's a little odd, but it's like this. And then we're going to do 10 divided by said number. We're going to the hundredths here, so it's going to be point divided by 5.14. And our answer, roughly, is going to be 1.9455. Yeah. Rounded up to here, 1.95. This being meters, that being meters. Don't forget to use our units of measurement, guys. And yeah, that's really all you guys needed from me today, huh? If you guys would like me to review any specific topic, please be sure to send me a message privately, or no, please be sure to send me a message privately. I appreciate your time. I hope you guys found this review helpful, and let me know if there's anything else you'd like me to cover, of course. Thank you for your time.